Hello. Today we're going to be talking about piecewise functions. Piecewise functions have different rules for different sets of things. So what I would like you to do here is read the warm-up and try to come up with the cost for A, B, and C given this context. So in a moment here, you'll pause the video and try it yourself and then come back to the video to see if you were correct. Okay, for A, you are taking 32 and you are multiplying it by the price, which is $10, because 32 fit into this rule, and so therefore you had this price. For B, 8 shirts would just be your normal $12 per shirt. And then the last one here, you have 85, and because it's more than 50, you're following this rule for that many shirts. This represents a piecewise function because based off of the number of shirts you have, you're going to end up finding your price different ways. So we're going to take this situation here and we're going to write about it in function notation. So function notation, as a reminder, is f of x. Normally you're used to saying like f of x equals 2x plus 3, where you just have one rule for whatever your inputs are. For this one, we're going to have 3 different rules based off of how many shirts we're buying. So the first case is $12 per shirt. Because it's $12 a shirt, 12 is your rate, so we write that as 12x. Your next case was $10 a shirt, and your final case was $8 a shirt. So these were the different rules on how you calculate your price. But the problem is we didn't use all of these different rules all of the time. They were for specific times. So for instance, the last one, you only used this rule if you ordered more than 50 shirts. So this down here is telling you when to use the rule. So this rule only applied if you ordered more than 50 shirts. The $10 shirt only applied if we were anywhere in between 11 and 50 shirts. So if we were in between 11 and 50 shirts, we would show that with this inequality, showing the number of shirts here would be somewhere in between those two values, including those values. And then the last one, or rather the first one, was $12 a shirt, and that started all the way back at the initial one. So if you started ordering shirts, so if you were somewhere greater than 0 shirts, but 10 or fewer shirts. So this is telling us when to use each of these rules, and then the rules themselves are telling us how we get our final answer. This is a piecewise function. All of that put together, there's different pieces. Let's go ahead then and take a look at some specific piecewise functions. So in the past, we've been talking about graphing absolute value functions. And when we see absolute value, we know it's going to be that V shape. Now that V shape actually can be broken down into 2 separate parts. The one part would normally be a line that looks like that. The other part is another portion of a different line. So half of our absolute value would be one rule, the other half would be another rule. And the dividing line is always going to happen through your vertex here. So if you're looking at this, if I were to cover up half of your graph, and I were to say, what's the equation of this line? You would look at that and you'd say, okay, well, here my slope here is 2, so it's going to be a 2x. My y-intercept here is 0. So my equation of this line is y equals 2x. So over here, this is asking when x is greater than 0. So if you're looking at your x values, on the right half of the graph are all of the x values greater than 0. And so on the right half of the graph, the rule would be normally y equals 2x. And then what happens if I cover up the other side? I cover up over here, and now it's saying x is less than 0. This is saying on the left half of the graph, which is over here, x is less than 0 because you're talking about the negative numbers. This line right here, if I were to say, what's the rule for that line? You would say, okay, well, here my slope here is -2, and my y-intercept is 0. So this line over here represents y equals negative 2x. But I don't have that whole line. I only have half of it. And so what's happening here is normally this rule would be this line, and this line would be this rule. But I only wanted the left half, or the right half of my yellow line, and the left half of my blue line. This is a piecewise function. So if we take a look at this specific example, what we would do is we would write it in function notation by saying f of x equals. You would pick one of your rules. So we said y equals 2x. That's our rule. And then we would talk about when to use the rule. And so the when to use the rule is talking about your x values. So for the first one, we had said on the right half of the graph is when x is greater than or equal to 0. So this part here represents the yellow part of the graph. The left half of the graph had a rule of negative 2x, and that happened on the left half of the graph, which is when x is less than 0. So this would be your piecewise function. Now let's go ahead and look at some more examples here because it takes a little while to get used to this notation. So we see that this is an absolute value graph. We see it can be written as two separate parts here. So the dividing line happens here at negative 2. So on the right half of the graph here, if the dividing line here is happening at negative 2, the right half of the graph represents all of the values that are bigger than negative 2. So this is the right half. The left half, because you're talking about negative 4, negative 5, negative 6, represents all of the values for x that are less than negative 2. So we have found our boundary here as split up into either the right half where your x values are bigger than negative 2 or your left half where your x values are less than negative 2. Then what we're going to do is we're going to write the rule for each of those halves. So the first one, let's take a look at the right half. So we're looking when x is greater than or equal to negative 2. This is talking about the right half of the graph. It's asking what is the rule for that line. So looking at it, you can pick a couple points here. Your slope here is negative 1, and your y-intercept is negative 2. So the rule for that half would normally be y equals negative x minus 2. So what we're going to do is we're just going to take the negative x minus 2 part, and instead of writing y, we wrote f of x over here. Now we're going to look at the other half of the graph. So we said this is the left half, so when x was less than negative 2, that represents the left half. For these ones here, our slope would be 1, and our y-intercept, oh, we'd have to keep going here. We don't have our y-intercept yet, so we have to extend our line here, and our y-intercept here would be 2. So our equation would normally be y equals 1x plus 2. So we're going to take the x plus 2, and that would be our rule for the left half of the graph. So again, the rule part, this is telling us what line is graphed. This is telling us what part of the line is graphed. So now let's go ahead and take a look at a couple specific examples. So looking at number 3, we're not going to have absolute value graphs anymore. What we're going to do is we're going to graph two different lines, but those two lines aren't a function. So what we're going to do is we're going to basically take parts of those lines and erase them and only have half of one line and half of the other. That's what this is showing. So let's go ahead and try to graph this, okay? So the first part here is the rule. The second part is when to use the rule. So if I had just given you, oh, I'm so sorry. If I had just given you y equals x plus 1 and I said graph that, you'd say, okay, I can do that. So my y-intercept is 1 and my slope is 1. So I'd graph all of these points and then all of these ones down here. And I would connect those points and make a line. So what we're going to do here is we're going to say we want this line, but we don't want all of it. We only want a portion of it. So to figure out which portion of it is, you have to look at when to use this rule. So when I see x is less than 2, what I am going to do is I'm going to say my x value I'm looking at is at 2. This is my boundary. I'm going to chop my graph right here. And x is less than -2 is going to be this side over here. So we're going to graph this top rule, but only this half of the graph. So if I were to chop it, I'd have this yellow half here and this blue half. The one I wanted is the yellow half because that's where x is less than 2. So what I'm going to do here is I'm going to then erase this other half of the graph. So I only have this one portion. And now I want to then do the same idea with this next line. So I'm going to graph this one in blue here. So if I would have said graph y equals -3/2 x plus 2, just by itself, what we would have done is we would have gone to 2 for my y-intercept, and then I would have gone down 3 and right 2, and up 3 and left 2. So you can imagine this is the whole line we are looking at. But the only problem here is while we've graphed this line, we don't want the whole line. We only want this portion of it. So x is greater than 2 is saying all of your x values that are bigger than 2. It's the same boundary as the last one. We just want this blue portion of the line instead of the other portion. So once we chop our graph here at 2, what we can then do is we can then erase the other part of our graph that we had done over there. So we only want this one down here. So you can see in yellow, this rule was graphed, but only the left half of it, and in blue, this line was graphed, but only the right half of it. So let's try another one here, number 4. So what we're going to do here is these are the rules, and these are when to use the rules. Oh, you know what? One thing I forgot. Go back to the last one. This last one, you notice how it had the or equal to? This means it's going to be a closed circle on boundary. So the closed circle on the boundary. So it's filled in right here. This does not have the or equal to, so it's going to be open circle on the boundary because it's only talking about when x is 2. So this one right here should be an open circle. Please make sure you have that there. The boundary will either have an open or closed circle, and you can tell that based off of the inequality that's there. So looking at this next one, the boundary for each of these is when x is 1. So I'm going to go ahead and chop my graph here. X is less than 1 on the left half of my graph, and x is greater than 1 on the right half of my graph. So what's going to happen is I'm going to graph this line, but I'm only going to graph the left half of it. And I'm going to graph this line, but I'm only going to graph the right half. So let's go ahead and graph the one in black first. My y-intercept here is -4. My slope is 2. So if I imagine this whole line, the only portion of the line I want is from my boundary to the left. So it's going to be these ones here. And at my boundary here, it's going to be an open circle because it's not or equal to. So what I can then do is just erase the other points and not even graph them. For my green one, what I'm going to do is I'm going to graph this line. So my y-intercept is up at 8. My slope is down 3, right 1. So I graph all of my points, and then I figure out which half I wanted. So I want the right half and the boundary at 1. So it's going to be everything here, and on my boundary, it would be an open circle. So you can see this green is that right half there.